Okay, in this next section we're going to give attention to derivatives of trig functions specifically. And we've covered a few of these theorems in some previous lectures, but these are also listed in your textbook as well as the proof of these. So if you'll look over that, that's going to be in, I believe it's section 3.4 of the text that we're using right now. But those are just some theorems to remember. And next we're going to give you the derivatives of the trig functions. Okay, so they're defined here. If you will, just pause it, make sure you have all these down. It may be a good idea to do note cards with all your derivative rules, and especially for these trig functions. Alright, so our first example is y equals 2 times the sine of x. So I'm just going to leave the, bring the 2 down. What is the derivative of the sine of x? Cosine of x. So we'll just get this. That's y prime. Careful with notation. Alright, so our second one, if I have y is equal to sine of x divided by 2, that's really just what? 1/2. Good, I'm glad you see that. So y equals 1/2 sine of x. So y prime is just the 1/2 that's there. What's the derivative of sine? 1/2 cosine of x. Good. Alright, just starting with the basics. 3 cosine of x. The derivative of cosine is negative sine, so I'm just going to put the negative out front. So negative 3 sine of x. And one more basic one, and then we'll branch out a little bit. So you get x plus cosine of x. What's the derivative of x? Just 1. And then what's the derivative of cosine of x? Negative sine of x, so our derivative is 1 minus sine of x. Okay, so we have x to the 4th times the cosine of x. What you need to distinguish is that we have two terms here, so we're going to have our product rule. First times derivative of second plus second times derivative of the first. So make sure you write that first step out and then go ahead and calculate. Okay, so that's the setup, and then the derivative of the cosine of x is negative sine of x. The derivative of x to the 4th is 4x to the 3rd. So pulling all the terms out front and rewriting, we have this. Also, if they just pulled the GCF out, although that's the correct solution, then it could be, what's that, a negative x cubed. So that would leave me with an x there. X sine x minus 4 cosine of x. Okay. You may or may not just be able to know what equivalent versions of these different solutions are, because your textbook sometimes can be a little bit tricky in how it presents the solution, and you can have calculated the derivative correctly, and then when you're checking your answer, just be aware that sometimes they factor out. Okay, so here we would just have y prime. What's the derivative of the first term? Negative 10. And then I would have the 3 that's there, but what's the derivative of the cosine? Negative sine, so I have minus 3 sine of x. Okay, so if I'm given cosecant x minus 4 square root of x plus 7, what do you suggest about this term? We rewrite it. Yeah, anytime we can rewrite and make it easier to do our rule, we would like to do that. So that would be x to the 1/2 power. And now we're ready to take the derivative. So y prime, derivative of the cosecant x is just going to be, look on your table, negative cosecant x cotangent x minus, what is the derivative of this term? So 1/2 times 4, which is just going to leave us with 2x to the negative 1/2 power. The derivative of this term is just 0. So if I was to see this answer, I may also see it like this if I rewrote it using the radical. Okay, cotangent x divided by 1 plus cotangent x. What derivative rule will we use? Quotient. So low d high minus high d low over the square of what's below. Set that up and then just calculate the derivatives in the first step. Okay, so that's the setup. We're going to do the derivatives here and here. Okay, so that's what we should have here. We're going to distribute this out and simplify the top, the numerator. Alright, and what do we see here with these two terms? So this term and this term will cancel out. And that will leave us with our derivative being negative cosecant squared x over our denominator, which is 1 plus cotangent x squared. Alright, let's say we're given a function like this, 4 over the cosine of x plus 1 over the tangent x. Instead of using quotient rule in this one and quotient rule in this one, just like in algebra, sometimes we algebraically rewrite the problem so that we can use power rule and it makes it easier. Is there any way I can rewrite this in terms of a trig function? What's 1 over the cosine of x? Secant x, right? So that's equivalently, you can rewrite this as 4 secant x as a rewrite step, plus what's 1 over the tangent? Cotangent x. Good. So just like when we can algebraically manipulate a problem before we take the derivative, same thing with trig functions. You can use any of your trig properties that you've known. And now we just evaluate f prime of x to be 4. What's the derivative of secant x? Secant x tangent x. And then the derivative of cotangent x is negative cosecant squared x. Okay, so know that you can do that. Okay, so we have this. What I need you to recognize is that how many terms are here? 2. And what about how many terms are here? Here. And just here is just 1, right? What we're going to have to do is product rule here. First times derivative of the second plus second times derivative of the first plus first times derivative of the second plus second times derivative of the first plus the derivative of this one. Then you would do all that out, simplify it, and calculate it. I'm going to let you do that on your own, and I'm only going to give you an answer to check here. So your answer is going to be y prime is equal to x squared cosine of x. This is going to be what it simplifies to. One more time, you're going to do the product rule to this, plus the product rule to this, plus the derivative of this. Add all those terms. So I want you to try that one and check yourself on it later. Okay, same thing with this one. You have 2 terms. So you want to use product rule. So you're going to do first times the derivative of the second, plus second times the derivative of the first. You simplify that out, and let's actually work this one. We'll work this one together. This one's got some... Alright. Okay, so this one just gets to be complicated. We did come back and do some trig substitution here. So first of all, just plugged in our derivatives there, multiplied this out, and then I decided to simplify in terms of sine and cosine just to see if anything would simplify. And so I rewrote this as secant as 1 over cosine, cosecant is 1 over sine, cotangent is cosine over sine, and then the cosine terms canceled, so that left us with this. On the right side, we did the same thing, but a sine term canceled. We're left with this, and then we rewrite, and this will be our derivative. Okay, we're short on time, so we're not going to work this one out in its entirety either. So I just want you to know, to be able to set this up, you do low d high minus high d low over the square of what's below. Now there's not really anything really tricky in there, other than at one point I want you to recall that cosine squared x plus sine squared x is equal to what? 1. That's the Pythagorean identity. At some point you'll remember that when you simplify. But other than that, after you apply the derivative rule, you should get 1 over cosine squared x, which is equivalent to secant squared x. Okay, so that's just your hint right there. You can try this one on your own using the quotient rule.